electrolysis. Where can we apply this? Okay, we know that electrolysis is breaking of ionic compounds by means of electrical energy. So we supply energy into it and we break this ionic compound. Okay, where can we apply this in our daily lives? And let me tell you, so many industries actually survive through this. In fact, what they do daily is this thing, and they produce quite a lot of minerals that are so important for our economy to grow, for our economy to produce jobs and everything, and also for the goods that we're seeing around. For example, the things we use to build our cars and everything, this electrolysis becomes very important. So let's see how it is applied. Okay, one way of applying our knowledge of electrolysis is through electroplating. I like this one. Okay, what is electroplating? Electroplating is coating one metal with a layer of another metal, either for protection. So you do that because you want to preserve this, you want to protect it, you want it to have a life, a longer lifespan, or you want to improve its appearance. Okay, let's see how it works. For example, you can have a spoon made of copper, and that spoon you can coat it with a silver to improve its appearance. So we can get a layer of silver around that spoon and we improve its appearance. We know bronze looks a bit dull, and so we want this to look a bit shiny and silver, and everybody would like to say, wow, where did you get this? This looks so nice. So we want to have a layer of silver around it. Okay, that's electroplating. Let's see how this happens. When you want to electroplate something, the metal that is to be electroplated, if it's copper, to be electroplated with silver, that copper, which is the metal to be electroplated, must be the cathode at all times. In other words, you must remember, what is a cathode? This is where reduction occurs. Okay? Now, if this is where reduction occurs, it means you are reducing an ion in solution into a metal solid by making it receive electrons. So if it's silver ion, you make it receive electrons to give you a silver solid. Okay, that's what is happening there. It has to be always at the cathode. Whatever you are electroplating has to be the cathode. Reduction must be happening there. Okay, now the solution or the electrolyte must be made of the iron of the metal to be coated onto the metal that is to be electroplated. For example, like we're talking silver and copper. If you want to electroplate copper with silver, the electrolyte, in other words, the solution in there, must have silver. It must be a silver solution, maybe silver nitrate, okay, something soluble. Okay, so it will be having the silver ions in that solution. That electrolyte must be of silver ions. Okay, next, to make another, now we're becoming specific. If you want to make one metal look silver, we will the electrolyte must be of silver ions, and the anode must also be of silver. In other words, that electrode must be made of silver as well. Okay, we'll explain this. The concentration of silver ions in solution remains constant throughout. Why? It remains constant throughout because the rate of oxidation of the silver electrode, which I'm going to show you now at the anode, equals the rate of reduction of the silver ions at the cathode. Okay, so that is why the solution there, if you have got your solution of silver there, so Ag plus. And then you've got your spoon there, which is your cathode with your energy here. So here it must be negative, positive, negative, positive. This electrode here is an electrode of silver. This is silver metal, piece of silver. When this one is taken out of solution by receiving an electron to become silver, at that moment an atom of silver there loses an electron to become Ag plus. So Ag atom loses an electron to become Ag plus there. So that if you started with 20 Ag pluses here, you always have 20 Ag pluses inside the solution, because the rate at which oxidation of the silver piece of metal equals to the rate of reduction of the silver ions in solution. Okay, now that is what is happening there, and we are going to continue to talk about this so that you can see. We're going to have a clear example again on how electroplating occurs. See you next time.